Hi, welcome to another video. In today's video, we are going to solve palindrome partitioning problem from the Leetcode. In this problem, they will give a string and we need to partition that string in such a way that all the substring resulted from that partition should be a palindromes. Let us consider this example where the given string is AAB and we can partition this string into two types of substrings where each string in this combination is a palindrome. If you observe this first list where the elements are A and B, A is a palindrome, this A is also a palindrome, B is also a palindrome. And if you observe the second set of substrings where A and B is considered, A is a palindrome and B is also a palindrome. So we need to partition the given string into substrings in which all the substrings are palindromes. So constraints are like the length of the S will vary from 1 to 16 and S contains only lowercase English letters. If we keep these things in mind, and let us go through the approach how we can solve this problem, and later we will code the same approach so that it becomes easy for us to understand the whole solution. Let's consider this example where the given example string is AAB. So our given string is A and B. So this is the given string. We need to partition it so that all the substrings in that partition will also be a palindromes. So how we are going to approach this problem? What we can do is we can start partitioning these substrings into substrings. We will start partitioning these substrings, and if it is a palindrome, then we will continue this partitioning. So how we are going to approach this problem is, first we will start with a substring A. Since A is a palindrome, what we are left with A and B. So we remove this A, and since A is a palindrome, we are left with this combination. And what is the other substring that we can make here? We can make AA. So if we start with AA, this is also a palindrome. So what we are left with is B. And if we choose another substring which is going to start with A, that is AAB. Since this is not a palindrome, this AAB is not a palindrome, we are not going to continue this path. But here we will continue the same thing, same operations. We will start considering what are all the substring which are going to start with A. So the first substring which is going to start with A is A itself. So since this is a palindrome, we are left with B. So if we choose another substring which is going to start with A, that is AB. So after doing this, we are left with an empty string. And here also we have one choice, that is we can start with B, and since B is a palindrome, we will be left with an empty string. So if you consider this example here, and here also we can move forward. So here also we can check with the B. Since B is a palindrome, we are left with an empty string. We did a mistake here, that is when we consider this substring AB, this is not a palindrome. So here we will not go till this path. So we will stop here. Whenever we meet something, so we will start with the original string and then we will start generating all the substrings which are going to start with the first letter. So that is what we are doing here. When we had this original string AAB, we started with substrings starting with A, that is A, AA and AAB. If this is a palindrome, then we will continue. We will remove this A and we will end up with AB. And when we consider this substring AA, we will remove this part and we are going forward with this B. But when we consider this substring which is going to start with A, that is AAB, this is not a palindrome. So we are not going to continue this recursion path. So after this, here also we will do the same thing. What are all the substrings that are going to start with A? So A is one substring and AB is another substring. Since A is a palindrome, we will continue this path, and if we remove a from this string, we are going to get b as a string. So since this substring, another substring which is going to start with a, this is not a palindrome, so we are not going to continue this path. So if we continue this recursion path, we have b, the only substring which is going to start with b is b. Since this is a palindrome, we are going to end up with, after removing this b from b, we are going to end up with a empty substring. So we are going to stop here. So whenever we end up with these empty strings, that means we have done partitioning our substring into palindromes. That is, if you observe this path, whatever the path that we are having, a and b, if we combine these things, that will result in our answer. So one combination is a and b. So this is one such combination. So whatever the path that we took to obtain this empty string, so we started with a, b, first we removed a, and then we removed another a, then we removed another b to get an empty string. So this will become one such combination where we have partitioned given string into a palindrome substrings. So another path where we end up with null substring is this path. So if you write all those combinations, first string is a, I am referring to this path where we end up with a null string. So first string that we removed is a, and then we removed b. So this is one such combination. So if you observe the first example, this was the expected answer. So for the given string a, b, these were the two answers. So I hope this approach is clear to you, so that we can implement the same solution. Let's start implementing the same solution that we have discussed here. So we are going to store all these answers in this vector. So vector I'm going to name it as combinations and we are going to store all the partitions into these combinations, and then we are going to call a generate combinations function, for which we will pass the string s, and along with s, what we are going to pass is, we are going to pass a current combination. So initially this will be empty, so we need to pass that as well. And after this function will update all the combinations, and then we are going to return these combinations. So we need to implement our generate combinations functions according to the discussed approach. So we are going to implement the same thing here. So void generate combinations. So the first argument is string yes, and second argument is a vector of strings which will have current combination. So then we will check whether our current string is a empty string. This is a base case for our recursion. So if this is the case, if not of s dot size, then this means we have partitioned our string into a set of palindromes and we have ended up with a null string. So at this point we need to push our current combinations into our answer. So combinations dot pushback current combinations, and then we will return from here. So otherwise what we are going to do is we will start generating all the substrings which are going to start with first character. So we need to partition this string into substrings starting with A. So let us write a for loop in which we will be able to achieve that. For int I equals 0, I less than s dot size, I plus plus, and in this for loop we will generate those current substring. Current substring can be obtained by a substring function for which we have to pass the starting index. Starting index will always be 0, and the length can be given by I plus 1. So this is what we need. So this will take care of this for loop, will generate all the substrings starting with A for this particular call stack. And once we generate the substring, then we need to check whether our substring is a palindrome. If our current substring, whatever the substring that we are considering, if this is a palindrome, then we need to remove this part from our original string. So if that is the case, then we need to remove that part from our current substring, current word. So what we should do is we should remove that part from this string. So we will push it to our current combination, because since our current substring is a palindrome, we need to push it to our current combination. Current combinations dot pushback current substring, and then we are going to call this function generate combinations, and for this function we have to remove this part. This means we need to start generating, in order to remove this we need to have this I index, so from where our I has ended. So we know the I value from where it has ended. We are considering till index I. That means we need to consider s dot substring of from I plus 1 onwards. So I plus 1 onwards, anything. So we can directly pass s dot size as well. For this length, for the substring function, first argument is from where we want to start the substring, and the second argument is usually the size. So here we are passing more than required, it is okay. That will be taken care by substring. Otherwise we can calculate the exact length which will be resulted after removing that thing. So that is the first argument and our current combination. And after that we need to remove. So once we come back from this recursion path, so we remove this and we consider this substring, but when we are going through this path, while removing A, we are still considering this substring. This means when the recursion happens through this path, and while coming back we need to reset to our original position. So what we are going to do is, since our current combination should be reset to this original position, current combinations dot pop back. So this is the overall approach. We have not yet implemented the function that is palindrome. So we are going to implement that function as well. This is a very simple function which will take a string s and returns true if it is a palindrome. So our start index will be 0 and our end index will be last index, that is s dot size minus 1. And while our start is less than end, if s of start is not equals to s of end, then we need to return false. Otherwise we will increment the start and decrement the end. So finally, if we don't find any mismatch, then we should return true. So this function will take a string as an argument and which returns true if it is a palindrome. So we are going to make use of this function here in this if case, because while moving from when we generate substring, we will check whether it is a palindrome. If it is a palindrome, then only we are going to continue with this recursive call. Otherwise we will just stop there. If you observe this example, when we consider this substring which is going to start with a, that is AAB, this is not a palindrome, so we will stop here. So here also when we consider this substring which is going to start with a, AB, this is not a palindrome, so we will just stop here. That is what we are checking here. So I hope this solution is aligns with whatever the approach that we have discussed. Let us submit this solution and check whether it passes the initial test cases or not. Okay, I think we have some current typo here. Current combinations. Current combination is the word that we have used here. Okay, I think here also we should take care of that naming. Let's see if we get any other errors. Okay, this solution is passing the initial test cases. Let us submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, you can check out other videos from my channel. I have given links in my description so that you can go through those related playlists in order to understand these backtracking problems. So I hope you enjoyed this video. Thanks for watching this video.